as part of the space station, this module is based on, the service module. As you do know that with the European, they have built up to 5 automated transfer regions, and the last one, the 5th one, has been launched a few days ago and docked to the space station also a few days ago. So what's the purpose of this spacecraft? Probably some of you already know the purpose of this spacecraft. Is to bring, absolutely, is to bring stuff. So it does mean that it is unmanned. There is nobody inside the spacecraft during the launch and up to the arrival at the station. But of course, you have to imagine, it's a 20-ton vehicle that is approaching toward the space station, which is 400 tons, something like this. Of course, although there is nobody inside the ATV, the astronauts, they are sitting inside this module during the rendezvous and docking process. And what they want less time than to control it from the ground, because the ground you have to reach a satellite and the satellite to, So let's go up. It's really cool quarter of the Russian cosmonauts. And during the approach of the ATV, the astronauts and cosmonauts are sitting not on chairs, they are sitting here, let's say, and they are going to monitor the approach of the spacecraft via this kind of screen that I showed you, together with a little screen here. For the malfunction, there is something very smart that we developed, and once again, things are usually very simple, and we want to rely, in case of critical situation, on something very robust. And this is something robust. What is it? It's called a malfunction table. And what does it mean? It means that during the approach, of course, the astronaut, they have the procedures. Okay? But you see, it's a lot of pages they have to go through, etc. And this is a kind of quick summary of the malfunction. During the approach, the astronauts are going to monitor all the parameters which are here. And depending on the distance from the station, in each column you have a certain range of the distance. This table tells them what to do. Example. Let's take range rate is the velocity during the approach. Between when the spacecraft is between 250 meters and 20 meters, the speed of the spacecraft should be less than 15 centimeters per second. If it goes over, it's a malfunction. If they notice that this parameter is going too high, the little color there is going to tell them what to do, and they will press on this button. Of course, when you get closer to the station, the reaction should be much more stronger, because if you have a problem with the speed, so it means the risk of collision is very close. Then for the same parameter, the color now will be red, for instance. So it means that strong action to get rid of the spacecraft as soon as possible. Also very interesting, you have a lot of technology, alphanumerical data, and you see all that. But think about it. If there is a problem with the spacecraft, with the onboard computer, how can you rely on these values? Because these values have been produced by this computer. So maybe it's not so good idea as the ultimate way to monitor to always rely blindly on these values. And for instance, for the distance from the ATV to the space station, you have this value here, 90 meters. How do I know that this value is valid or not? How I can know this is for sure is using a range ruler. It's very, very simple technology. So it's really made out of plastic. Yeah? We made it here, we send that to space, and here you have your tool. So the idea is for the astronaut, they will, let's imagine this is their ATV that they see, okay? They will just put this range ruler above it, and they will simply read what is written there, and it will give them the range. And it's done. And this cannot be wrong. You have it, you don't have it. If you don't have it, of course, we don't go for rendezvous. But once you have it in your hands, it's there. So, and this is very important for space business. Another thing, the corridor that I spoke about. There were two codes. How to visualize this corridor? Very simple. You have just an overlay like this. It was also printed very, very simply. You have this kind of overlay, and you see you have concentric circles. Actually, they represent in 2D the corridors. If you see the spacecraft at a certain moment in the middle and then deviating and going above, trespassing one of these circles, it means that it's leaving the corridor. If it leaves the corridor, so they know what to do. Once again, it is robust. Once you have it, nothing can happen. And this is always the same rule for manned spaceflight. Of course, we can use the state-of-the-art technology for everything, but as soon as a man is involved, still we want to rely on something very robust, you know? So, now let's go on the other part, which is ATV. Those ones can go through the hatch if you want. Me, I will just turn around. But
oh, I want to go there. I mean, you don't. How often do you get to go to a hatch? Si liksom dalla parte rossa.
Ma hanno riprodotto anche le...
No, dai, ci proviamo.
Ma sì.
Ti senti un attimo... Ma non mi ricordo.
Okay.
For progress is the docking system, which is here. I will say some words about that. So here, what you see is the ATV attached to the space station, and the hatch has been opened, which is this stuff. And this hatch is also a docking system. This is a system that ensures that at the moment both spacecraft touch each other, one is captured by the other. Then, when both spacecraft are together, there is a system of hooks that closes in order to maintain both spacecraft together. Once the spacecraft are together, it's possible to open this because the rest of the spacecraft is attached at the level of the circle there. So you can then open this. And this is a representation of a docking system, which is a Russian docking system. Why? Because we are docking to the Russian part of the station. So what we did, we bought their technology to install it on our spacecraft. That's why the ATV project is so much linked with the Russian space program. So here we have opened this. The astronaut then can penetrate, and you will find this inside. If you check once again on YouTube, you will see pictures or videos of the inside of ATV with Alex. Look, it's really like this. So what you have cargo bags. Because it's a cargo spacecraft, it's made to bring food, to bring clothes, to bring equipment, experiment, all what you can imagine. So it's really made for that. Then, in addition, you can also transfer water outside, yeah?
Stefan, come on.
Yeah,
Let's
momento.
change.
No, momento. Norbert can start. Yeah. So, outside there are tanks that contain water, for instance, and via this equipment, it's possible to transfer the water from the outside, the tank, into this kind of little bucket here, which are called EAC, and you find this little bucket everywhere in a space station is the way to maintain a water, potable water, for instance. But of course, to transfer water is not that simple in space because you don't have gravity. So when you open here a valve, nothing is going to flow. So you have to connect it to a system of compressor in order to suck the water. Also, at the end of the mission, it's possible to reload all the tanks outside with the waste. It's possible. And then it's just the opposite. Okay? So, we have to move because my dear colleagues want me to then move. Yeah, you saw that? Yes, the reason is that you need a bit of protection once you open the hatch. The first time you open the hatch to enter here, because you don't know what is the atmosphere at that moment. The atmosphere can be polluted with some residual dust or whatsoever that was hidden behind the racks and that's populated inside or the main area during the launch due to the vibration. It's just to avoid that Alex gets too much of this dust, residual dust at the very first moment. That's the only reason. There's no toxicity whatsoever. It's really to protect the eyes and the nose.
Has this ever happened?
What?
The polluted air.
Yeah, it's always. Well, just after the launch and the first time you open the hatch there, and also due to the difference in pressure between this spacecraft and the other, there is always a little bit of pollution, but it's nothing really critical. It's normal and everything is going to be clean very soon. And actually they clean the air. One of the first actions of Alex is to put inside the spacecraft what is called a scrubber. It's like a vacuum cleaner sucking all the dust which is still in the spacecraft. It's one of the very first actions. But it's not. Okay, let's go. So here you are in the Eurocom room. You got an introduction about the Eurocom function by my colleague Lionel. He was on the stage and he explained, and together with Andrea, they explained you a little bit what was the main role of the Eurocom. Do you remember? Who was not sleeping yet at that time? Allez. Surveying, yeah, it's yes. Sorry? Fire test? No. No.
Communications.
No, not really. Something different. But you are almost there. Yeah, more or less. So actually, when we have our astronaut or the astronauts in Columbus, which is the European laboratory, performing some experiments, some European experiments, there is someone sitting here or in Munich, not far away from Munich, and controlling all the operations which are performed on orbit, not so only controlling, but also on request, providing recommendations about a certain number of operations. Of course, this person doesn't work on its own only. There is a full control center in Munich that can also monitor the various parameters of the Columbus. But as Lionel mentioned, there is only one person who is allowed to speak to the crew, and this is the Eurocom in the case of Columbus. You have the same in the United States, where the person in the control center who speaks with the astronaut is called the CAPCOM, capsule communicator. So if you come here along, you may see a lot of displays. The display which is here allows the person to select the various communication loop. This communication loop can be communication with the ISS flight director, for instance, who's located in Houston, or to be connected with the Columbus flight director, who's located in Germany, somewhere else, and also can select the space-to-ground voice communication. As you saw earlier, during the in-flight call, Jules was speaking and you were asking questions to Alex. In order to do that, we have to select the right space-to-ground channel. You can do that from here, you can do that from Houston, you can do that from other cities. On the display, which is there, you have displays showing you some of the parameters of Columbus. For instance, I don't know this display in particular, but you may want to monitor what is the status of the thermal control system. And the display that you will call up will tell you the exact status of this system. So that at any moment, you know here on the ground what is the behavior of the Columbus. Here behind, you can recognize just with the colors what Lionel showed you and Andrea.
But the old understanding is that whenever Alex arrives in Columbus, he is about to proceed. We should not offer him to confirm that we are good until step with the physical switches.
So here, what you hear, I don't know exactly the communication with whom is the communication, but Eurocom is checking a procedure at the moment. He has opened a procedure that most probably an astronaut is doing at the moment, is performing the same procedure. And the guy on the ground is checking that everything is fine and also provide recommendations, for instance, skipping some steps which are not necessary, like that here. So what the images that you see there, they are real-time images. In the middle, at the bottom, you can recognize the numbers where it was a few minutes ago. And on the right side, you have it's probably in the American part of the station, and you see one cosmonaut and the other one I don't know if it's cosmonaut, it's probably also cosmonaut. They are also performing whatever operations with the laptop, so it's in real time. On the top, in the middle, this image, it's an image taken from an experiment. So there is, I don't know what is the experiment. But it's transmitted, of course, to the ground.
Sorry, there was quite some crosstalk of space to ground 2. Please, could you repeat?
And then on the right side, you have all the parameters for the orbit of the EAC observatory moment. What you can see is the speed, 7,600 meters per second. It's close to 28,000 kilometers per hour. The height of the ISS is quite high at the moment, for 223 kilometers. And the other.
So this is okay, copy that. But in step 6 does not really say something about the stalling, and then there is this dedicated activity. So I would not assume that there is really a mismatch.
On this panel, you have all the caution and warning indication. If there is anything wrong happening about the station, it will pop up here. So that's not always, but the astronaut can also see that as immediately was a problem. So you will get this kind of information to the failure, and this tells you all the communication session. Because the fact that now we are getting an image is due to the fact that we have enough relay satellites in order to transmit this information to us. And it happens from time to time that you don't have communication. Not at all, because there is no satellites, or the way the satellites are configured cannot provide us with any data. This is what we call the lack of loss of signal. There's always an acquisition of signal. It tells you at what time you are going to get the signal and at what time you are going to lose the signal.
The duration.
And the duration. So that it allows the people on the ground and also the astronauts to make a schedule, a very good schedule, and to plan for all the activities on board if there is a need of having communication. This, you can see the time to the next cruising. So the guys are going to go to sleep in. Yeah, they have their individual stuff. They have their own system or own alarm clock, and on their watch or something like this. But anyway, they will be waking up if they don't. Because if they are there on orbit, it's not for leisure. No? They are there to work, and they work 8 hours a day. So that's like normal job. Crew to sleep in 7 hours 30 minutes.
this sounds like a very strange
then
question,
you
but I
see
have actually my
for,
USB
8
space
hours.
open, and I'm seeing on the PDU1 a current draw for VR. I don't expect that, so I assume we are wrongly connected here. Can you really confirm that the VR is off, and on PDU1 outlet 1 and PDU2 outlet 6 there is no current draw?
With the ground, where the ground is going to tell them, okay guys, today you did that. Tomorrow,
Thanks a lot.
what we ask you to
I
do
think you are
is
right, and we are just wrongly
operations,
connected, but
prepare
just to be on the
this
safe side.
procedure, because tomorrow you will have to do this, you will need that tool. It's just a briefing. Then they start their day like this, with this communication. Usually they receive some greetings, etc. on the ground. It's really this moment. Then they go
Okay,
for
because
the
I have here different
all day.
indication. I
Yeah,
need to cross check
end
with
of
our
the day,
pieces
they
where
have
we are
to
connected to.
With
Thanks a lot.
Everything. It's yes, it is. Yes, it is. So it's, for us, it's very convenient. For the American, it's not, and for the Russian, it's not. And the Japanese, it's even worse. But for us, it's very good because all people can work with normal working hours. Yeah, it's day and night.
Okay.
So now,
And this green?
this is a spatial area, which is called an anomaly. Where there is a special
South Atlantic anomaly.
electromagnetic field there is different from all the rest of the surface of the Earth, and then there might be interferences here in this area. It's just due to the nature of the Earth, how the electromagnetic field is spread over the Earth. So it's very well known. No, it's steady. It's it's okay. We have to go because people will go.
Okay. So we have to going down. Now, to go towards the North Pole, you should change the changing and that's a lot of turbulence in that. It's very difficult. So on top of that, I'm not sure that what you would have, what you can cover if you stay only above the North Pole and the South Pole, I'm not sure that you will cover in the same way the Earth as you can cover it with an orbit which is with an inclination like 51, for instance. Do you understand? This is difficult to answer the question. A node is a connector between different systems. various modules, right? And on my left side is the entrance to Columbus Laboratory, and on the right side it is the entrance to the Japanese laboratory. As you can see from this picture, it's full of items. Full. And this is one of the biggest problems with the space station, all these items, because you need to keep track of all these items. You cannot lose any of them, because if you do, you may get into trouble. For instance, some years ago, there was an experiment that was prepared on the ground by hundreds of scientists, engineers, etc. It took years to define this experiment, to build the equipment, etc. And a lot of money. So the equipment is ready for the experiment, maybe it took 5 years. It is sent with a Soyuz cargo or a Soyuz space probe or Progress cargo up to the space station, and then it is stored somewhere. Because maybe the experiment will be performed only in 7 months after the arrival of the experiment on board space station. So the guys, they put it somewhere, and then everyone forgot about that. Then 7 months later, at the ground, during the daily planning conference, called the astronaut saying, okay, tomorrow you will have to perform the experiment, blah, blah, blah. Please prepare the procedure, take this procedure, blah, 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 and you need this tool, this equipment, and this. So the guy was looking for all this equipment. He could not find it. He could not find the equipment. So it means that the day after, it was impossible to run this experiment. So it means a lot of money in the trash, a lot of hope, and what you can imagine from all the scientists on the ground gone, and it's a disaster. So that's why the astronauts, they really have to pay attention where they put stuff. But in order to help them, they have a database where when they put an object somewhere, they have to scan. There is a scan code there, and barcode, and also a barcode where they put it, and then it is stored in the database, and it helps. But still, if you see videos on YouTube, wherever the inside of the space station, you really wonder how
It really looks confusing.
Yes, absolutely. But it's well, it's like that. And you have this everywhere. And you see in some of the corridor between two modules, you see it's full of bags.
My mama will be happy
everywhere.
about my My mama will be happy about my bedroom.
It would be
She
like
would have seen this one.
yeah.
That's something worse.
Just to look first at the inlet of the
I know that.
fuel.
Okay.
Something.
For the small items, yes. If you don't find the stuff, you go underneath the on the ground, or it depends where it is, but where the fans are located, and where there is a grid that protects the area from the rest of the fan system. Usually, you will find the small items blocked on the grid, and that's it's very common. You do that. Yeah, it's a trick which is very well known by the astronauts. So you can enter in a Columbus.
Then, do they find the stuff?
No,
Never.
we don't know where it is. And it has been trashed with Progress cargo, because you know sometimes, regularly they put all the trash in the Progress, but there's so many things that it can very well be. So, and you are here in a Columbus. It's the rear size. It's exactly like this in terms of size. And when you saw Alex earlier, he was in this kind of module. And actually, let me think. we could see, so it was this, the camera was located there, like this camera, and Alex was here somewhere. Yes, sorry. And here we could see on the hatch the German flag.
Yeah,
It was this configuration. Alex was there, and that was the camera taking the picture. Well, on all this, of course. So now, no, I it's less expensive and everyone is happy. So it's a laboratory. So what you see here are these this ground there, this platform there. And actually, in reality, it's not transparent like this, but we use it because we have to teach all the systems there. These are the systems that makes that Columbus can live. It's powered, that he receives telemetry, he receives the power, he receives all the thermal thermal loop that he needs, etc. It's just to make this house or this module functioning. And then what you see on the side are dedicated to experiments. Okay, so you have to imagine in a house you have near the garage all the boiler, etc., for the house, and also the electrical panel. So it's there. And then what you do in your house, you have a kitchen, etc., So these are the kitchen where they are going to perform experiments. Each part here is called a rack. This one rack, a second rack, is a name. And these racks are always dedicated to host one type of experiment. One rack is dedicated to experiment for physiology, for instance. Another for biology. Another one for fluid physics. So when I say that these racks are dedicated, it means they accommodate all the systems which are needed to get experiment dealing with the subject I mentioned. Of course, the need for a biological experiments is different from a physics experiment. For instance, for biology, depending on what you do, you need a protective area to work inside like this and this. In this rack, you find also centrifuge, for instance, which is needed to maintain the samples or whatsoever. Here, my colleague, what they do, they teach this area as a system in a whole. So they are not going to teach the experiments here. This module is made to teach all what you see there, how this house functions. And then the experiment themselves, they are taught in other places. You saw at the entrance, you have all these blue rooms. Inside the blue rooms, you always have a high fidelity representation of this one, where my colleague teach them the experiment themselves. Okay, so it's separated, so that everything is not mixed. It's really the way it works. Yeah, you can also see there. It has been a long time I haven't seen them. Two gold plates there. Actually, in the real Columbus, there are also two gold plates, but on these plates you can find names that you cannot find here. It's plenty of names, and they are the names of all the engineers who contributed to build the spacecraft, which is really nice. It's kind of
hundreds or tens
or hundreds. You know this the project Columbus started a long time ago, and it took there was a lot of delay in for the launch. It was supposed to be on orbit much earlier than 2008. Finally, it was in 2008, but it was supposed to be much earlier. So there a generation has worked on this project.
Not thousands again?
No, not thousands. No, not thousands. Hundreds. Yeah, and mainly German, German, Italian, French. That's where the main contributor. Yeah? Okay, so let's go outside. From Aachen, I remember a young student, he came here for an internship 3 weeks, and it was many years ago. And at that time, he was hesitating, what should I study? Should I study physics or aerospace engineering, etc. And we had some chat. And I met him maybe 6 months ago. Of course, he has grown up and now he's an adult. And he decided to study aerospace engineering there in Aachen. And he became absolutely passionate by this. And the trigger was his internship here at EAC. Yeah, it's wonderful when it happens.
Did you get a very good
Yeah, he came here at EAC for an internship, but a short duration internship.
I read there are only a few per year.
Yeah.
Really few. So
Few, not so few, but where have you read that? Where have you read that?
in EAC, it's not that much
Yeah,
for students.
it's we have a lot of pupils coming for short duration, so maybe we have 50 per year, but they stay 2 weeks.
Yes.
For the
Yes, of course.
long duration, probably we have something like
Katie.
yeah, it's already something. Huh?
I think that's
Yeah, yeah. Okay.
Just one.
Okay.
Great, super, thanks.
There's a wonderful video that we made at EAC that explain you the launch sequence of a Soyuz spacecraft. And we were speaking about internship. We made this video with this intern in aerospace engineering. Came here at EAC for 6 months, and it's a very cool video that explains really from the launch up to the arrival on orbit, all the sequence of the Soyuz spacecraft. And there is another video which is undocking and re-entry explained. I don't know if you have ever learned anything about the re-entry of the Soyuz spacecraft, but it's a little bit more complicated than internship, and we explain that very easily in this video. And now we are preparing a rendezvous and docking video, which will be great. On ESA. ESA YouTube. You type undocking explained and you will get it immediately. Yes. And if you watch it and if you have questions, I will answer the question, of course. I do that. But also if you have a recommendation that you think that it's possible to make things better, to show this as such, always welcome. Always welcome. Yeah. Check that.
Essen. Aber für